everyone. On behalf of Thinknyx Technologies, I'm excited to welcome you all for another amazing video tutorial. Today we are going to learn about Rancher K3s. This video is prepared by our Kubernetes expert Abhishek Majumdar and is presented by Madhuri. Let's have a look at the agenda for today's session. In this tutorial, we are going to give an overview of Kubernetes, popularly called as K3s, and we'll discuss its architecture. Further, we will understand the differences between K8s and K3s, followed by advantages of K3s, and at the end, we will see K3s in action. So without any further ado, let's get started. So let's have a glance at Kubernetes Overview. Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a robust platform for deploying and orchestrating container-based workloads. The key features of Kubernetes is its ability to automatically scale applications based on demand and capable of dynamically adjusting the number of replicas based on resource consumption and user-defined metrics. Restarts and replaces container that fail. Kills container that don't respond to the user-defined health check and ensures optimal performance and efficient resource utilization. It offers powerful service discovery, load balancing capabilities, and automatically assigns a unique IP address and DNS name to each service, enabling seamless communication between different components of an application and distributing incoming traffic across multiple pods. With K3s, we can easily define and manage complex application configurations using declarative manifests, which can be YAML or JSON format. It also takes care of the necessary actions to maintain the state of the objects, ensuring applications are always running as intended. Kubernetes has become the de facto standard for container orchestration, enabling organizations to efficiently deploy and manage their applications at scale. Architecture of Kubernetes. In its simplest form, Kubernetes has master worker-based architecture. Master is dedicated node where we run majority of Kubernetes core components like kubeAPI server, etcd, controller manager, scheduler, etc. In short, master node is a brain of Kubernetes architecture and is responsible for user interactions to deploy and manage containerized applications, which eventually runs on worker nodes by default. The worker nodes are dedicated nodes where we run our containerized applications, and hence, while onboarding new containerized applications, Kubernetes provides us with the flexibility to scale out our Kubernetes cluster by adding additional worker nodes. Now, moving on to the history of K3s. K3s is a lighter version of Kubernetes distribution developed by Darren Shepherd in Rancher Labs. During some experiments and testing, he found it takes significant amount of time in setting up the Kubernetes cluster. We mean Kubernetes cluster. To address this issue, he carefully analyzed the Kubernetes source code and eliminated many binaries and dependencies. This is how Rancher K3s came to existence and became famous by discovering lightweight Kubernetes for specific use cases. Let's understand some more insight to K3s discovery. Rancher had their own enterprise Kubernetes distribution known as Rancher Kubernetes Engine. So Darren was intimately familiar with the Kubernetes source code. He started picking it apart, removing all the extraneous content that wasn't necessary to run workloads. He has created a single binary solution that unpacked to include container D and the network stack, the control plane server and worker components. SQLite as distributed DB instead of etcd, a service load balancer, a storage class for local storage, and manifests that pull down and install other core components like core DNS, and traffic proxy as an ingress controller. This is how K3s was actually invented. K3s is a lightweight Kubernetes distribution under 50 to 100 MB, consuming less than 512 MB of RAM and 1 core CPU, with revolutionized resource containered environments, enabling Kubernetes to run on systems which include 1 GB of RAM. K3s and the CNCF. The Kubernetes distribution conformant CNCF, which means that a workload that runs in one certified distribution like K8s will run on another certified distribution like K3s. CNCF opened the door for K3s installation in environments like wind farms, satellites, airplanes, vehicles, and boats. Interest picked up from governments who wanted to use K3s in air-gapped environments that would benefit from its minimal attack surface. Realizing that what started as an internal project with a limited scope was now in the hands of community, Rancher handed over K3s to the CNCF. Rancher K3s shortened in name to K3s. And it is the only Kubernetes distribution in the CNCF landscape that is owned by the CNCF. K3s is Kubernetes which bloat stripped out and a different backing data store. That said, it is important to note that K3s is not a fork, but it's just having core Kubernetes functionalities and remains close to native Kubernetes. Let's move further to know what exactly is K3s. Let's summarize K3s. Over time, Kubernetes has evolved to provide users with a faster, easier, and cost-effective methods of deploying clusters. In 2019, SUSE, formerly Rancher Labs, introduced K3s as a streamlined version of Kubernetes that eliminated the time constraints associated with cluster deployment. By selectively removing unnecessary overloads from the Kubernetes source code, Rancher Labs successfully created a single binary that functioned as a complete Kubernetes distribution. K3s ensures that YAML configurations designed for Kubernetes will seamlessly apply to K3s clusters. K3s is now recognized as a fully compatible and CNCF conformant Kubernetes distribution, conveniently packed in a single binary that encompasses all the necessary components for running Kubernetes. K3s is a fully open source Kubernetes distribution which is absolutely production ready. It has a very small binary sized K8s distribution for dev and prod like environments, which requires very low resources. In fact, K3s is highly suitable for edge computing. Let's move to K3s architecture. K3s architecture consists of a server and an agent, which is similar to master and worker node concept in K8s. K3s supports different cluster types, each with its own architectural considerations. The most common cluster types in K3s are single server setup and high availability setup. Now let's move to single server setup. In a single server setup, K3s runs with a single server and one or more agent nodes. The server node handles the cluster's control plane responsibilities, including managing the cluster state, scheduling and orchestrating workloads. The agent nodes execute the workloads and distribute them across the cluster, providing scalability and resource distribution. The single server setup is suitable for small to medium sized deployments where simplicity and resource efficiency are prioritized over high availability. It offers a straightforward and efficient way to deploy and manage Kubernetes cluster without the need for complex setup for additional infrastructure. Now moving on to high availability setup. In a high availability setup, K3s ensures continuous operations and fault tolerance by employing multiple server nodes and agent nodes. This configuration provides high availability, load balancing, and resilience for critical applications and demanding workloads. The server nodes collaborate to manage the cluster's control plane services, such as maintaining the cluster state, orchestrating workloads, and ensuring fault tolerance. If one server node goes down, the remaining node seamlessly takes over its responsibilities to maintain the cluster's availability. Agent nodes in an HA setup execute workloads and distribute them across the available nodes, enhancing performance and scalability. Load balancing capabilities ensure that resources are optimally utilized and workloads are even distributed across the cluster. The high availability setup is recommended for production environments where high availability, fault tolerance, and scalability are crucial. It provides a resilient and robust platform for running critical applications and handling demanding workloads while ensuring continuous operations and almost zero downtime. In short, the single server setup of K3s is ideal for small to medium sized deployments, offering simplicity and resource efficiency. On the other hand, the high availability setup enhances fault tolerance and provides scalability for critical production environments. Now let's discuss K3s and Edge Cluster. K3s is a lightweight Kubernetes distribution designed for edge computing. It enables the deployment and management of containerized applications closer to data sources, reducing latency and conserving bandwidth. Edge clusters consists of geographically distributed edge devices or servers. Benefiting from K3s streamlined architecture, reduced resource requirements, and support for ARM64 and ARMv7 architectures. With K3s, organizations can leverage Kubernetes features like scaling, service discovery, and load balancing in edge environments. This is beneficial for IoT, smart cities, industrial automation, and remote locations with limited connectivity. K3s in edge clusters ensures real-time data processing, improved performance, and enhanced reliability at the edge. Let's see the key differences comparing K3s to K8s. Comparing K3s to K8s is not entirely valid. K3s is a Kubernetes distribution designed with a smaller memory footprint and tailored for edge computing and IoT environment. The choice between K3s and K8s depends on the specific use case. K8s was developed by Google while K3s was developed by Rancher. However, both K8s and K3s are open source and are approved CNCF projects. Let's understand few of the key features between K8s and K3s. K8s is a larger and more comprehensive Kubernetes distribution, while K3s is a lightweight version specifically designed for resource-constrained environment with a specifically smaller binary size. K8s has a larger memory footprint compared to K3s, making K3s more suitable for environment with suitable resources. K8s requires more time and effort to install and deploy, while K3s can be installed and deployed quickly with a single command. K8s is a more complex system with a wide range of features and options, while K3s simplifies the Kubernetes experience by removing non-essential components and reducing complexity. K8s has more dependencies and requires additional components for certain functionalities, while K3s includes essential components out of the box, minimizing external dependencies. K8s is designed for large-scale deployments and can efficiently utilize extensive resources, whereas K3s optimizes resource usage and is better suited for small-scale or resource-constrained environments. K3s is specifically optimized for edge computing environments, offering better performance, reduced latency, and efficient resource utilization in cases where we have limited connectivity and low-powered devices. K8s has a large and mature community with extensive documentation, support, and resources, while K3s has a growing community and benefits from the support of Rancher Labs and the Cloud Native Computing Foundation CNCF. Now let's move further and discuss about the benefits of K3s. K3s offers numerous benefits that make it a compelling choice for Kubernetes deployments. Lightweight. With a binary size of less than 100 MB, K3s is significantly smaller than traditional Kubernetes distribution. This makes K3s well suited for resource-constrained environments and devices with limited compute, storage, and networking resources. Installing and deploying K3s is a really super quick, requiring just a single command. The entire process typically takes less than 30 seconds, enabling rapid cluster setup. Thanks to its small size and minimal dependencies, K3s offers a smaller surface attack, enhancing security and reducing potential vulnerabilities. This is particularly important in edge computing and IoT scenarios where devices are exposed to external threats. K3s comes with essential components out of the box, including CRI, CNI, a service load balancer, and an ingress controller. This comprehensive feature set simplifies cluster setup and eliminates the need for additional installations or configurations. Easy updates. K3s benefits from the reduced dependencies, making it easy to update and the distribution with minimal disruption. Upgrading K3s involves replacing the binary and restarting the process, allowing for seamless updates without major downtime. K3s supports remote deployment scenarios and can be bootstrapped with manifests to install additional components after the cluster comes online. This flexibility enables easy deployment in remote environments with limited connectivity. These advantages make K3s a powerful and versatile Kubernetes distribution, capable of running in a wide range of environments and addressing the unique challenges. Why K3s? By now we understood K3s is highly available, certified Kubernetes distribution designed for edge computing, Raspberry Pi, IoT appliances, and for remote locations. K3s is CNCF certified. Production-ready Kubernetes distro with increased popularity and wider community support in recent years. K3s setup. We would be coming up with part 2 of this tutorial covering how to set up K3s with single server cluster mode. Thank you for watching us. We really hope you liked our video. Please like and subscribe and also click on the link below to know more about Thinknyx. Bye. We shall see you in our next video. Stay tuned for more update from us.